Okay guys, let's take a look at our lesson for today. It's on inverse functions. That previous lesson was on inverse trig functions, and we learned how to find the derivatives of the inverse trig functions. This we're going to be in a general inverse function, and that lesson typically a little bit difficult for students. So I'm going to go through the background. I want you to understand conceptually what's going on, and then on the second slide is where we get to the problems that you'll see, like on the AP test, multiple choice, or etc. But I want to go through the background first to see what's going on. So let's remind ourselves what inverse functions are. I've given us a couple over here. So x cubed and cubed root of x are inverses of each other. If you recall from Algebra 2, remember how you would test to see if it was inverse? You do a composite like f of g of x, and if you've simplified that and got x, you're like, oh yay, it's inverse, or g of f of x. Okay, I'm seeing some of you remember, some of you are like, what are you talking about? Yes, you used to do that in the old days, right? You used to see if functions were inverses of each other by that technique. These are, just trust me that they are inverses. If you want to do that, you can. You can do the f of g of x or g of f of x if you like, but they are inverses. And remember what makes them inverses. What makes them inverses is the x's and the y's are switched, right? They're not reciprocals, they're inverses. Their x's and y's have been switched. So we're going to do a little investigation here and look at that, basically that concept. So if I put a 2 in here, 2 cubed is 8. And if I put an 8 in here, the cubed root of 8 is 2. And so this is just a demonstration of that property that I was just talking to you about. Inverses, their x's and y's will flip. They're reversed of each other, which is a key to today's lesson, that we recognize that. That's one important fact. So now that we have like the functions, kind of conceptualized, let's look at the derivatives. Maybe there are some things that go on with the derivatives that we can look at. So let's take the derivative of this first one. The derivative of x cubed would be 3x squared, and the derivative of the cubed root of x would be 1/3 x to the negative 2/3. That's a 1. Okay. So it doesn't seem to be much. I mean, there's some similarities between the derivatives, but nothing perfect. So let's just keep going. And let's see if there's anything similar or some kind of a pattern with the values of the derivatives. Maybe there's something there. The derivatives themselves, they're little bit, I can go with something, but let's look at the actual values. So if I put a 2 in here, so 2 squared would be 4, 3 times 4 is 12. So we know f prime of 2 would be 12. Now let's investigate what happens over here. And I'm actually going to put an 8 in here again, so this would be 1/3 times the cubed root of 8. So that 8 squared, the cubed root of 8 squared. So if you're not good with big numbers in your head, like I'm not, you're probably fond of the factor tree. I love factor trees. Yes, I'm old, but it doesn't matter. I still use factor trees, because I can't think of what the cubed root of 64 is in my head. Some of you probably have that memorized, but in case it's bigger than that, let's see if it's a bigger number, what would we do? So I would break it down into its factors. Knowing that I'm looking for groups of 3, right? So I have one group of 3, one group of 3, so I know that that's 4. 2 times 2 is 4. I know that the cubed root of 64 is 4. So I have 1/3 times 4, or 1/12. And look at the situation that we have with the values of the derivatives. The values of the inverse derivatives are actually reciprocals of each other, which is kind of a strange thing, since we say over and over again that inverses aren't reciprocals, right? There we switch the x and the y. Actually, their derivative values are reciprocals at that same, at these spots right here. The derivative values are reciprocal. So that's that's a concept that we need to kind of wrap our minds around. That yields this formula right here. You're like, yay, we get another formula, woohoo! Okay, there's another formula. This one right here is the one that we'll memorize. So the derivative of an f inverse, the inverse of f, we can find by this formula. And this is going to be important on the next slide. I'm just introducing the formula to you. We're not going to use it yet. Okay, so that formula we'll use on the next slide. And let's look at this diagram right here. I put this on here to try to give you some more background on inverses. So this blue graph and this pink one, these are inverses of each other. You recall another basically concept is they reflected over the line y equals x. Remember that? If you graph them, the inverses would be a reflection of each other over y equals x. So this is just showing these are inverses, and we see that our x and y values have been flipped, and it's just showing you what happens with the derivative values, the slopes. The slopes are reciprocals of each other. So that's just another, I guess, just carrying out this concept a little bit more so you can see visually what's going on. So we've talked about numerically how they're different and similar. We've talked about formulas, and now I'm showing you graphically how the concept plays out. Okay, are we okay so far? Okay. This next problem, this example right here, isn't a typical one that you would see. This is more of really a pre-cal problem. We're still in the background, as we're not to calculus yet. We're still looking at the background of what are inverses. The only calculus stuff we've done so far are these derivatives right here. So just a little bit more exploration, and then we will jump into the second slide, which are the problems that you'll see on the AP test. The first thing we need to review is what a one-to-one function is. That's the first thing that we need to review. And so you may remember, I would bet that you probably remember how to find a function in general. So let's look at the parent parabola just as an example. Remember how to figure out if it's a function. Remember that vertical line test where if you draw a vertical line, it can only go through the function once and then it's a function. Remember that? Okay, so that we know that y equals x squared is a function. The one-to-one test, if we're doing it graphically, is a horizontal line test. And so if I draw a horizontal line, I need to only go through the function once. Okay, so that's how we would do it graphically. And we can see from this that the parabola is not a one-to-one function because that horizontal line goes through it twice. So if we're able to graph it, we can look at it and tell whether it's a one-to-one function or not. We can do that horizontal line test. But we also need another way to know whether it's one-to-one, and that would be using calculus. We can use calculus to determine if it's one-to-one. And so what we would do, so again, we could graph this and we could see and look to see if it's one-to-one, because that's what it's asking, is determine if it's one-to-one. But let me show you how to do it with calculus. So we would take the derivative, and then we would investigate the behavior of the derivative. If the derivative is, let's just look what this one is. If we look at it, I think you can recognize that it doesn't matter what x value I put in here, this derivative is always going to be positive. Right? It's always positive. This derivative is always positive. So let's think about what that means. That means that all the tangent lines have a positive slope. Right? All of them do. All the tangent lines have a positive slope. And that means that it's always increasing, right? All of them have a positive slope. So it's always increasing. Now what I'm saying that it means that this function is always positive and always increasing. Excuse me. This one is always positive. This one is always increasing. The derivative is always positive. The actual function is always increasing. If we have a function that's always increasing, is that going to be one-to-one? Yeah, right? Because this one decreases then increases. That's what causes us to have our horizontal line go through it twice, right? Because it does both. It increases and decreases. If it was only increasing, right, we would just have it would pass. It would pass the horizontal line test. So it is one-to-one. So this particular one is yes. This is one-to-one. Okay, that's how you could tell by calculus. Now it wants us to find the derivative of it. And this is kind of a fun thing to do. It's just unfortunately not practical for the problems on the second page for us to be able to do this. But I do want us to go through and find this derivative. The first thing, it wants us to find the derivative of the inverse. We don't have the inverse, so let's get the inverse. Let's switch the x's and the y's. So we would say x equals y to the fifth plus y plus 1. We basically just switch the x and the y's. Now this is the inverse function. Okay, that is the inverse function. So now we're going to take the derivative with respect to x. So the derivative of x would be 1. The derivative of y to the fifth would be 5y to the fourth dy dx. Plus derivative of y would be 1 dy dx. And the derivative of 1 is 0. So this is implicit differentiation, which we've been working on for a little while now. So now we know we would isolate the dy dx. So dy dx is, let's see, we'll factor it out. 5y to the fourth plus 1 equals 1. So dy dx is, what is this, 1 over 5y to the fourth plus 1. So that would be my derivative. Now, the thing that's, I guess, not very convenient for us in general is that there are no x's in here, there are y's. And if we're given an x value, if we want to find the inverse at an x value of 2, we can't just plug in an x value of 2 here. It's a little bit more complicated. So going through this work generally will not help us in the problems on the next page, but I wanted you to know you can find the derivative. It is possible. All right, questions so far? All right, so let's get to the second page where the typical questions are that you would see on the AP test. So let's go here. There are really like two categories of types of problems that you'll see. One is where you have all the information that you need, and probably extra. I'm just saying, probably extra. Everything that you need and more. The second kind is when we don't have everything and we're given a formula. All right, so we're going to learn how to do both of these. So the first one, and these are formulaic. We need to know that formula on the other page to be able to do these. So the very first one, we're given f of 3 equals 5, and we're given a derivative value, and we're asked to find the derivative of f's inverse at 5. That's what we're asked to find. The first thing that I would like to do is set up the relationship with this point right here. So if f of 3 is 5, then I know f negative 1 of 5 is 3. Right? That's what it is. That's the relationship between a function and its inverse. And this, I think, is where we get really mixed up with this switching thing. So I recommend that you write it down. When you take that and you just write down that relationship. So now let's go ahead and write down the formula from the other page. What we're asked to do is to find f inverse's derivative at 5. That's what we're asked to do. And the formula from the other page would be 1 over, and then it would be f prime of f the negative 1 of 5. Okay, so that is my formula. All right, so this is right here. That's why I recommend that you write that relationship down, because it'll be clear. Now, you don't have to. Maybe you can do this in your head. I don't know. But write that relationship down. So what I'm going to do is I'm going to replace f negative 1 of 5 with the 3. Or I'm going to use substitution. So let's rewrite. So that's going to be the same as 1 over f prime of, okay, we're replacing this with 3. Okay, we okay so far? So now I just have to look for this value. Do we have f prime of 3? So here we go. There's f prime of 3. F prime of 3. So I'm going to substitute. I'm going to take 7/2, and I'm going to put that in place of f prime of 3. See how we have all the pieces that we need? We fix our complex fraction, and we have 2/7. So that is the inverse of f's derivative at 5. So that's what we do. It's all in abstract, right? We wouldn't be able to do this without a formula. We would need the formula. We work through the formula. We get the answer. And like I'm saying, probably you would have like extra information up here. And you have to determine what you're supposed to be using. Okay? Questions on that one? Yes?
So because the earlier formula, like after it had in the form that we just used, it said like 1 over dx dy. So anytime you do that, you know, that's going to be like 1 over the, once you read it through and you know that you have the right derivative given, like it's 1 over that derivative.
It is. If you know you have the right derivative, then it is just because that's the relationship between the inverse and the regular function, is that the value of their derivatives are reciprocals. So yes, if you can figure out which one it is, it's 1 over that. Okay. Now in the second example, they don't give us anything except an equation. We wouldn't be able to do that here. So this requires a little bit more work. And so let me walk you through the steps, several steps that are involved. The first thing that I would do is I would go about setting up this information. This information is critical for our formula. I need to find that out. That's the first thing that I would do. And so we have this value of 2. In the inverse, this is an x. But in the original, it's a y. Right, so I'm going to take this 2 and I'm going to put it in place of y. Okay, so that's my first step. I'm looking to get this relationship right here. Now, we look at this, and before you panic and think, oh, or no, maybe you're excited, like, oh, that's like a P over Q. Don't really go there. Okay, you're not going to need to use algebra. This is just going to be a simple number. It's not going to be a radical. It's not going to be anything crazy. It's going to be something that you can do in your head. You should not have to do any algebra to get the answer. Now you can, but you shouldn't have to. It's going to be like a 1 or a -1 or a 1/2 or -1/2. It's going to be a regular number. Okay, so perhaps it might be easier to put the 2 over there. Maybe it's easier to tell how to make 0 than it is how to make 2. I don't know. It's up to you. So I'm going to just move the 2 over. Okay, so we have to think to ourselves, again, it's going to be, we're just looking for one answer. They're not going to give you 2. It's going to be 1, and it's going to be the easy one. Now, are there more than 1? Well, probably. There's probably 3, but we're looking for 1. So we look through here. What could x be to cause this to be 0? It looks like x would be 1, right? If I put a 1 here, 1 plus 2 minus 3. Okay, so x is 1. So now I'm going to write this relationship down right now so that I don't get confused. So I know that f of 1 equals 2. Right? That's what we just determined. F of 1 equals 2. That means that I now know that f -1, so my inverse at 2 is 1. So I've established this relationship right here, which is important. Okay, the same relationship that's there. We okay so far? So I established that. I need to get that relationship. Once I get the relationship, I'm going to write down my formula and see what I need. So let's write our formula down. So our formula is f -1 prime of 2 equals 1 over f prime of f -1 of 2. Okay, so let's look at this. This f -1 of 2. We have that, don't we? It's right here. F -1 of 2. So I'm going to replace this with a 1. So equals 1 over f prime of 1. Okay, I'm going to replace it. So now I need to find what f prime of 1 is. Is that within my reach? Is it possible for me to do that? Sure. I don't have f prime, but it's a pretty easy matter to find it, right? I just go over here. So f prime of x is 3x squared plus 2. And I need f prime of 1. So f prime of 1 is 3 times 1 squared plus 2, or 5. Okay, so my answer is 1/5. So you'll see a problem like one of these two, or some kind of a variation, maybe with a chart or something. Are we okay with that, with the formula? All right.